Hello again. This is Math 2231 coming to you from the College of DuPage, and the title of this lecture is Solution to Reconciling Xenos Paradox and High School Algebra. And as always, please be attentive learners while watching this video. Part A, we were to reconcile Xenos Paradox with high school algebra. And so, if we let t be the time in seconds until Achilles catches up with the tortoise, which we'll call t, they will catch up with each other when the distance that they have traveled from the distance that they are, I guess I should say, from the starting line of Achilles are the same. So this is the distance Achilles is from the start, because he went at 10 meters per second for t seconds, and he was starting at 0, and distance is rate times time. Now, the distance that the tortoise is from the start was different, because it still is distance equals rate times time, but here is the 10 meter head start that the tortoise was given. So we have 10t is equal to 10 plus t. So you can solve that for t. 9t is 10, and you dive through, and t is 10 over 9 seconds. So in just over a second, high school algebra tells you that Achilles would catch the tortoise. Zenos paradox then works this way. So Achilles is here at time 0, and the tortoise is here at time 0. So at this instant, the distance between the two of them is 10 meters, and the elapsed race time is 0. But then the race begins. And so the story was, well, what happens when Achilles reaches the spot where the tortoise would be? And you said, well, the tortoise would be a little further along. So here's the snapshot. Achilles is at 10 and the tortoise is at 11. Now, at this point in time, the distance between Achilles and the tortoise is not 10, it is 1. And the elapsed race time is not 0, it is 1 second. Let's move to the next slot of interest, and that is when Achilles gets to where the turtle was at this point in time. So Achilles now is at 11, but and that didn't take very long at all, because he just has to move 1 meter. In fact, and the tortoise continues to move. The tortoise now is at 11.1. So the distance between Achilles and the tortoise is 0.1 meters, and the elapsed time between the previous snapshot and this snapshot is 0.1 seconds. Let's do it one more time, but it keeps on going. So now we say, what happens when Achilles reaches where the tortoise was there? So Achilles reaches the 11.1, but now the tortoise, and again, that didn't take very long at all, the tortoise is now at 11.11. So the distance between Achilles and the tortoise now is 0.01. And the elapsed race time between the previous snapshot and this snapshot is 0.01 seconds. And this continues, and so on. So the distance between Achilles and the tortoise shrinks rapidly in the limit and reaches 0. And if we add up the infinite series of times elapsed, we'll end up with the total time is going to be 1 plus 0.1 plus 0.01 plus 0.001 plus, and it goes off to infinity. Now this then is the same thing as all of these decimals are 1/10. So this is 1 plus 1/10 plus 1/10 squared plus 1/10 cubed plus so on and so forth. Now, and it goes off to infinity. Now, you know from your pre-calculus that this is an infinite geometric series. And we know from our pre-calculus that the summation as n goes from 1 to infinity of a times Rn is equal to a, the first term. Actually, that should have been n equals 0. The first term, because there it's just 1, and you're not multiplying by the 1 over 10. So that should say n equals 0 is a over 1 minus r. whenever the absolute value of r is less than 1. This is a geometric series. So you see, here's the geometric series. The first term is 1, and the multiplier is 1 over 10. So this becomes 1 over 1 minus 1 over 10. That's 1 over 9 over 10, and that's equal to 10 over 9. So you see we got the same answer here. So we have resolved or reconciled Xenos paradox with high school algebra. Now, the mathematicians of the day were baffled because you see this part over here involves limits, but now we cover it in our pre-calc courses. Now, part B dealt with the lamp that you're turning on and off, and the answer to this is the lamp is neither on nor off. The limit really doesn't exist. And consider the following proof. We were concerned with what happened at 2 minutes. Now, if you tell me that the light is on, I can ask you, when did it turn on before that? And you reply, whoa, at a point called t star, where t star is something less than 2. But we know it will be turned off sometime between t star and 2, because there is some number, capital N, where 2 minus 1 over 2 to the capital N is between those two numbers. And that's going to be true for n sufficiently large. So that is going to be a contradiction, because that was not when it was turned on and still on at time 2, because it was turned off in between. An identical argument exists if you argue that it is off. So the limit doesn't exist. The lamp is neither on nor off. As you look at this video and think about your work, it may be useful for me to talk a little bit about high stakes assessment rubrics. If this problem were on a high stakes assessment worth 10 points, I would give you 3 points for a correct answer and a correct explanation for part A, and 3 points for a correct answer and explanation to part B. Now, if you made an authentic effort, that means you did some legitimate thinking, but didn't get either one of those correct, you might get 4 points there. So that's what I would tend to do, or think about this in terms of rubrics for high stakes assessment problems. And using the high stakes assessment rubric on your work can be useful for assessing how you're doing in the course, and if you should do more. I don't know. Although I don't know if you should do more or not, that's for you to decide. Although the LSA rubrics could be even harsher, because I have take-home protocols you can get help, they generally are about learning, and the grading is more relaxed. Now, this is good because that counts for your grade, but please realize that the LSAs are only 1/3 of your grade, and so it is important that you are growing as we're going through the course. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important, and of each other. We're all in this together. May God bless you all.